Assalamualaikum. Hello everyone. I hope you're doing great. And yeah, this video is about a problem that is dealing with moment. Moment is the turning effect of a force. This is going to be the last lesson that you'll have to study in this semester. And it's not that difficult, but we didn't do a lot of practice regarding this one, and that's why when I'm making this video. This question is coming from past paper of June 2023. And we're going to be solving the first one. It's paper 2, and this is the first question. This first question is about moment, and so let's get started. Now the first part, a pencil has a weight of 0.16. Let me use that. Yeah, so 0.16, that's the weight. Newton. What is the mass of the pencil? We don't know the mass, that's what they're asking. And G is always known as 10 Newton per kilogram. So we know that W is always mg. So you can do this, the triangle trick, just to know how to make the mass as the subject, and it's gonna be W over G, right? So it's 0.16 over 10, which will make it, don't need you no more. Yeah, so it's going to be 0.016 watt kilogram. But the thing is, all of these, you can see that all of them are in grams. So we have to convert this one into grams first, and then see which one can be applied. Yani. And all you have to do is just times this with 1,000. So it's 0.16 times 1,000, because 1 kilogram is equal to 1,000 grams. And so it is going to be 1, 2, 3. It is 16 grams, which means that it is number B. That's a simple one, right? So now we're going to the moment question. The diagram shows the pencil with one end resting on a small block. What does that mean? You see, you can do it yourself. Put the pencil on whatever the table that you're studying on or anything, and you'll find that if you don't support the pencil from the end of the pencil is going to fall down, and it's not going to fall down like in a straight line. It's going to be like going that way. I'm sorry, it's not exactly from here, but you know, it's not going to fall down. If you hold it from this part, it's going to want to turn this way. Why? Because the weight is affecting the pencil and make it wants to turn. Since it is resting from that part, it is kind of like bend from here, and that's why it will turning effect. You see, that's the meaning of moment. So here, how can you stop this turning effect because of the weight? You can stop it by supporting it from this part. As I told you, try it yourself. You're gonna see that this is that way. The pencil tends to fall in kind of a clockwise or anti-clockwise. I don't know about directions, but you need to support it in the other direction, in the opposite direction, to cancel this moment. So we know that moment clockwise is equal in moment to moment anti-clockwise if we want to find a balance. If I don't want anything to turn, moment clockwise should be equal to the moment anti-clockwise. And so here, let's go see the question. I'm just explaining things before even seeing the question. So here, the diagram shows a pencil with one end resting on a small block. A finger provides an upward force to keep the pencil horizontal. It makes sense, right? Since the weight is going that way, which means that the pencil wants to rotate this way, I need to support the other way around, which is here, which will make another moment that way. So those moments are, one of them is anti-clockwise, one of them is clockwise. I think this one is the anti-clockwise, this one is the clockwise, this one. So the first part, I the weight of the pencil is 0.16. We know that. Calculate the moment of the weight of the pencil about the pivot. Use the formula. The formula is already given. Nice. Which is moment is equal to the force times the perpendicular distance. Perpendicular distance. Let's see what do we have here. Let's clean this place first and then see. Now, this is where the weight is applied, or this is where the weight is acting, let's say. And this is called the center of gravity, where the whole weight is being is acting. This is where, which most of the time is kind of in the middle or the center. As mentioned, it's the center of the gravity, or the center of the mass. So it is shown to you in this example, so you don't have to think about it that much. Here we have the weight applied here. The weight is not applied here, nor anywhere. It is where it is at this point, which means that the perpendicular distance is 3.7. Now, what is the force? As we mentioned, it is the weight. It is written in the question. We know the weight is a force, is a type of force. So we know that moment, and please be careful not to mix the two. Let me do it in another way. Moment is going to be, why it doesn't want to disappear? Okay, moment is going to be kind of a big M, and mass is going to be a small one, okay? So the moment of the weight, or the moment anti-clockwise, is going to be the weight times the perpendicular distance. The weight is already given to us as 16 Newton, and you times it with the distance, which is 3.7. Now, 3.7 centimeters, usually I would be saying, please be careful of the units, blah, 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 but I won't say that right now. You know why? Because here, they want it, in the actual question, they want it to be Newton centimeters. They don't want the Newton meter thing. So you have to be careful not to waste your time converting units when it's not needed. Okay? So yeah, all you have to do is just get your calculator and find the answer. And I have mine here. And yep, the answer is 0.592 Newton centimeters. Only two numbers after the point, two significant numbers are enough. So it's that way. Even if you wrote like 0.6, it's not wrong. Newton centimeters. You have to be careful with these. We didn't have to convert it because that's what is they asked us for, the moment in Newton centimeter, not Newton meter. So I hope it's clear. Now let's go to the second part of B. State the moment of the force. What are they talking about here? Let me clean it again. So here we found the moment of the weight, right? Now we want to find the moment of the force of this one. Now I know it's going to be that way. It's going to want to do this here. So what is the moment of the force? Nothing is given to us except for the distance, but the magnitude of the force is not given to us. Actually, you don't need it, because we know that moment clockwise is equal to the moment anti-clockwise. No, let's go that way. So moment clockwise is equal to the moment anti-clockwise, as long as the pencil is balanced. And it is balanced. It's saying here that it's resting in a way that the upward force is kind of like making it balanced. So there's no momentum. Those two will cancel each other, which means that we just found out the momentum, not the momentum, the moment of the weight, which means that the moment anti-clockwise. And now we know that both of them are equal. So this one is going to be the same. The moment of the force is going to be equal to the moment of the weight. So it's going to be the same. Now, that part, it's all about the balance. So you either write the balance or the anti-clockwise equal to moment clockwise, or you can write the moment of the weight is equal to the moment of the force. All are correct. Now show that the force is 0.08. How can you do that? We know that the moment is equal to the force times the perpendicular distance. Even if you forget that, it is written here. So what can we do with these information? We know that the moment, clockwise, anti-clockwise, they are equal. So this part here for the force is equal to, as we found here, is equal to 5.9, which is the same as the moment of the weight. And the force, that's what we're trying to find. So it's going to be the same here. And the distance. Now, where is the perpendicular distance that the force is applying? That's between the force and the pivot. Now we have the pivot here, and the force applying here. It's acting here. So this is the distance. The distance is 7.4 centimeters. And so we're gonna write it here, 7.4, yeah. And you have to rearrange it. F is equal to 0.59 over 7.4. And again, where is my calculator? And where is my calculator? Yep. You just use it and you will find out that the answer is going to be something like that. And even though the number is not that nice, but it's the same. So we are correct. Easy, right? Good luck.